In this video, we are going to discuss the general properties of interhalogen compounds, and the first property is bond strength. The bond strength of interhalogen compounds, it depends upon electronegativity difference between the two halogens involved in the formation of interhalogen compound, and bond strength of interhalogen compound increases as the electronegativity difference between the two interhalogen compounds increases. Now consider the halogens iodine, fluorine, bromine and chlorine. For iodine, electronegativity is 2.52, fluorine 3.9, bromine 2.62, chlorine 2.95. So when interhalogen compound is formed between iodine and fluorine, then electronegativity difference between iodine and fluorine is 1.38 and its bond energy is 277.8 kilojoule per mole, and enthalpy of formation for this iodine monofluoride, it is minus 94.6 kilojoule. Now consider the formation of bromine monofluoride. There is an involvement of fluorine and bromine here. Electronegativity difference between fluorine and bromine, it will be 1.28. So as electronegativity difference decreases, bond energy also decreases. For bromine monofluoride, bond energy is 249.4 and bond formation energy, it is 74 kilojoule per mole. So as electronegativity decreases, electronegativity difference decreases, bond energy also decreases and enthalpy of formation also decreases. Now consider the formation of bond between chlorine and bromine. In that case, electronegativity difference between bromine and chlorine, it is 0.95. So electronegativity difference still decreases, and therefore the chlorine monofluoride has a bond energy of 248.9 and it is less than the bond energy of bromine monofluoride. Even the bond formation energy is also less for chlorine monofluoride, it is 56.5. And therefore there is a correlation between difference in electronegativity and bond enthalpy or bond energy and bond formation energy. So lesser the electronegativity difference, lesser is the bond energy and or bond formation energy. Again, the strength of bond, it depends upon the covalent and ionic characters. A bond with partial ionic character, it is stronger than a bond which is purely covalent or purely ionic. Now next property is enthalpy of formation. Already we discussed this property. The enthalpy of formation of interhalogen compound increases with increase in electronegativity difference between the halogens, and therefore iodine fluorides are most stable and have highest bond energy, because electronegativity difference for iodine fluoride is highest, and therefore these compounds are most stable and iodine fluorides have highest bond energy. Consider this order. Iodine monofluoride, it is more stable than iodine monochloride, which is more stable than iodine monobromide. So here electronegativity difference decreases and therefore stability also decreases. Even as compared to chlorine monofluoride and bromine monofluoride, iodine monofluoride is more stable and stability decreases in the order iodine fluoride, then bromine fluoride and chlorine fluoride. In interhalogen compounds, less electronegativity or less electronegative halogen shows positive oxidation state and act as a central atom. For example, in iodine fluoride, iodine is less electronegative than fluorine, and therefore iodine acts as a central atom. It shows positive oxidation states like +1, +3, +5, +7, etc. And iodine always acts as a central atom. Sometimes chlorine and bromine also act as a central atom because it shows positive oxidation states like +3 or +1, etc. But fluorine, as it shows -1 oxidation state, it never acts as a central atom. So central atom always shows positive oxidation state. Now interhalogen compounds, these are more reactive than pure halogens like chlorine, bromine, iodine. There is an exception, fluorine is even more reactive than interhalogen compounds, and therefore interhalogen compounds are more reactive than halogens other than fluorine. And the reactivity order is chlorine trifluoride, it is more reactive than bromine trifluoride, which is more reactive than iodine heptafluoride, which is more reactive than bromine pentafluoride, which is further more reactive than iodine pentafluoride, and iodine pentafluoride, it is more reactive than bromine monofluoride. So here in this order, bromine monofluoride, it is the least reactive, and chlorine trifluoride, it is the most reactive. Interhalogen compounds are better halogenating agents as compared to pure halogens. Interhalogen compounds are soluble in organic as well as some of the inorganic solvents. Now next property is thermal stability. Thermal stability of XY type of interhalogens decreases with decrease in electronegativity difference. Electronegativity difference between two halogens like X and Y. And the order of thermal stability is iodine fluoride, it is the most thermally stable, or it is more stable than bromine fluoride, which is more stable than chlorine fluoride, which is more stable than iodine chloride, which is further more stable than the iodine bromide, which is stable than the bromine chloride. So here in this order, electronegativity difference slowly or gradually decreases, and therefore thermal stability, it is also decreases. Thermal stability decreases. In this order, iodine monofluoride, it is the most thermally stable, whereas bromine monochloride, it is the least thermally stable. Interhalogen compounds undergoes addition reactions. For example, when alkene is treated with iodine monochloride, there is an addition of two halogens, that is iodine and chlorine, across the carbon-carbon double bond, and we get addition compound. And therefore interhalogen compounds undergoes addition reactions. Certain interhalogen compounds are unstable and they undergo disproportionation. So during disproportionation, oxidation and reduction occur simultaneously. So unstable interhalogen compounds undergoes disproportionation. This is because during disproportionation, the stability increases and there is a gain in bond enthalpy or bond energy. For example, when 5 moles of iodine monofluoride undergoes disproportionation, there is a formation of 2 moles of iodine and 1 mole of iodine pentafluoride. Now the bond energy for 5 moles of iodine monofluoride, it is 5 into 277.8. For one bond between iodine and fluorine, bond energy is 277.8. There are 5 such bonds, and therefore 5 into 277.8. This is for reactant. For products, especially for 2 moles of iodine, it is 2 into 149. For 1 molecule of iodine, bond energy is 149, and therefore for 2 molecules of iodine, 2 into 149. So here there is a formation of iodine pentafluoride as one of the product, and there are 5 iodine fluorine bonds, and bond energy for iodine fluorine bond is 267.8. there are 5 such bonds, and therefore 5 into 2 67.8. okay, so sum of bond energy for 5 moles of iodine monofluoride is 1389. Similarly, for iodine it is 298, and for iodine pentafluoride it is 1339. So for reactant it is 1389, and sum of bond energy for products it is 1637. So bond enthalpy or bond energy for product, it is greater than the bond energy of reactant, and therefore there is some gain in bond enthalpy or bond energy, and therefore reactant has a tendency to form the product, and because of this there is a disproportionation of iodine monofluoride to form iodine and iodine pentafluoride. So total gain in bond energy, it is obtained by simple formula: bond energy of the total bond energy of the products minus total bond energy of the reactants, that is 1637 minus 1389. this is equal to 248 kilojoule per mole. So during disproportionation reaction there is a gain in bond in enthalpy, and therefore easily disproportionation occurs, and comparatively unstable interhalogen compounds becomes stable. Okay, so this is about the general properties of interhalogen compounds. In next video we are going to discuss the structures of interhalogen compounds.